Hello everyone, welcome back. So today we will be entering chapter 13, which is on gas laws and kinetic theory. So this is our second final chapter for this semester. So the first subtopic is on ideal gas equations. Before that, there is 3 subtopics for this chapter. So let's go to the first subtopic, which is on ideal gas equation. So in this subtopic, should be able to solve problems related to the ideal gas equation, and then you should also be able to discuss the following graphs for an ideal gas. Basically discuss means you have to be able to draw this graph if you were to ask in exams lah. I'm sorry for the noise, it's my kittens playing in my room. Okay, so there is 3 laws that you need to know. The first law is on Boyle's law. So Boyle's law is focusing on constant temperature. So it is at constant temperature, and then the pressure is then inversely proportional to the volume. Okay, so pressure is inversely proportional to the volume. So if the temperature is constant, we then can get an equation which is this one. This is for Boyle's law at constant temperature. Okay, this is for constant temperature lah. So Boyle's law is about constant temperature. Then these are the graph of Boyle's law. So as it goes through a different pressure and volume, the temperature will stay constant. Okay, so this is what the graph is telling us. Semua ni mesti dia punya, what do we call, the temperature mesti constant lah. Okay, alright, ada lagi kah? Nope, that's basically for Boyle's law. Make sure you are able to use this equation. Okay, the second law is on Charles' law. So this one pula, volume is directly proportional to its absolute temperature. Absolute temperature meaning it has to be in Kelvin. Okay, it has to be in Kelvin. So this should be in Kelvin. And then this is focusing on constant pressure. So this is for constant pressure. So when at constant pressure pula, the volume is directly proportional to the absolute temperature. Okay, so if the pressure is constant, we can then get this equation lah. Alright, and then this are the graph of Charles' law. This is basically telling us that the pressure will be constant as it goes to a different value of volume and temperature lah. Okay, right, and then Gay-Luz, I don't know how to pronounce it, but this is on pressure law. So it states that the pressure is directly proportional to its absolute temperature, and this is focusing at constant volume. Okay, so this is untuk constant volume, and then this is again in Kelvin. Alright, so in this chapter mostly semua ni dia punya temperature you have to change it into Kelvin lah. Okay, so if the volume is constant, we can then get an equation for the pressure law, Gay-Lussac's law, whatever. Right? Okay, what else? So these two are the graphs untuk this pressure law lah. Okay, alright, make sure you are able to draw the graph if it is asked in exam. Okay, now we go on to equation of state for an ideal gas. So an ideal gas is a gas that is perfect, meaning that it obeys the 3 gas laws. Okay, the 3 gas laws that we learned just now lah. Okay, and then if we consider an ideal gas in a container that has a change in its pressure, volume and temperature as shown in this diagram here. So at the first stage it is experiencing this what do we call this, a constant temperature. Okay, at this first stage the temperature is constant, it is kept constant. Okay, kalau kamu tengok sini kenapa T1 and then T1, so the temperature is constant at the first stage. Okay, and then as it goes through the second stage, the pressure is the one that is kept constant. Okay, so it is undergoing two different stages lah. So it is experiencing ataupun it is obeying the three laws. Okay, so the first stage is the first law lah, which is the Boyle's law. So we can get this. Oh, okay, I haven't rearranged this. I'm gonna rearrange that for your notes. So basically we will then obtain this equation for the first stage, and then this is for the second stage lah. Okay, so if we equate them together, we can then get an equation which is PV over T equal to constant. Okay, that constant is actually, we then consider 1 mole of gas at standard temperature and pressure. So at standard temperature and pressure, these are the variables lah. Okay, this three ni. So from this equation, we can then equate ataupun let R lah. Okay, we label this constant as an R. Okay, letter R. So this R is actually the constant which is known as the Molar Gas Constant. Okay, it is the same for all gases. This is the constant lah, yang sentiasa constant. Boleh faham? So this is where we obtain this value, which is it is 4 at standard temperature and pressure. Okay, so this equation here, PV equal to RT, ini untuk 1 mole of gas saja. Okay, that's why we always use PV equal to nRT, because this is for n mole, berapa mole lah, n tu berapa mole saja. Okay, and then we have Boltzmann constant K, which is defined as this one shown here. So if we use this, we can actually use the number of molecules instead of just the number of moles of gas lah. Okay, so we then have two equations lah, PV equal to nRT ataupun PV equal to nKT. N untuk number of molecules lah, bukan N untuk number of moles. Alright. Okay, so number of moles of gas pula, we can actually calculate it using this two formulas here. Okay, so M gas is the mass of gas, and then M besar ni molar mass of the gas. This is also MR lah. Kalau kamu nampak di soalan MR, this is the molar mass of the gas. Dia punya unit is gram per mole ataupun kilogram per mole. Okay, and then this is our Avogadro constant, which is the one shown here, and then N, capital N, is the number of molecules. Okay, so if you are given these variables and then you have to find the number of moles, just use this formula lah. Okay, same goes to this one here. Alright, so that is basically the theory part for the first subtopic, which is ideal gas equations.